Welcome to Mr. Sweeney's AP Physics C class. These notes are on section 5.4 power in our energy note packet. And power is the rate at which work is done or energy is expended. And mathematically, we represent power by work divided by time. Power is a scalar quantity. And our equation is power equals work divided by time equals force times distance divided by time, also equal to work or force times velocity. These are all algebraic relationships between power, work, force, and velocity. And P is power, W is work, F is force, D is displacement, and V is your average velocity. For our units of power is the watt. And we use the letter W to represent the unit of watt. Don't confuse this with W for work. And what is a watt? A watt is a joule per second. If you're looking at it from a calculus point of view, power is the rate at which work is done, so that's dW dt. Or we could also look at it as the rate at which energy is expended, dE dt. Let's go through an example of this. I'm going to do the first and third examples. In this first one, we want to know what is the maximum height a motor having a power rating of 20.4 watts can lift a 5 kilogram stone vertically in 10 seconds. So we're going to use this equation. We're going to use power equals force times displacement divided by time. And the force that we're acting against here is the force of gravity. So we have 20.4 watts of power. The force is 5 kilograms times 9.8 meters per second squared. Over the distance we're trying to find, and that happens all over 10 seconds. And that yields us a displacement of 4.16 meters. That is how far this motor can pull this up in 10 seconds. That's a maximum. The second problem, I'll have you complete this one right after you watch this video. We'll talk about that in class. And we're going to go over the third one as an example. In this one, we have a truck weighing 30,000 newtons. It's driven up a hill. And the hill, the length across the incline is 1.6 times 10 to the 3 meters. That's 1,600 meters. The area itself is 800 meters above the starting point. The trip took 480 seconds. We want to know what power it required. In this scenario, we have power equals force times displacement divided by time. And our force is going to be the force of gravity times the change in height. The work done against gravity solely depends on the change in height. So the change in height in this scenario is 800 meters. And that's what we use, 30,000 newtons times 800 meters. That's our weight times our displacement divided by the time it took, and that yields 50,000 watts of energy. And that'll be it for this section. The other two sections will be up, and we will talk about them later on in the week.